Okay, this video is going to be covering the rest of section 7.2. We're going to discuss the idea of arc length for a parametrically defined curve. So if we have a curve that is defined by parametric equations, x of t and y of t, like we've been considering, we can find the arc length as long as both x and y are differentiable, meaning you can take their derivative. And the way we find the arc length is with the following integral. So it's the square root of x prime squared plus y prime squared. Remember, this is just another notation for x prime and y prime. So let's take a look at an example. Find the arc length of a curve defined by the equations, and it says x of t is 3t squared, y of t is 2t cubed, t goes from 1 to 3. So again, this is just a straightforward application of the integral, so we do need to know what dx dt is. Dx dt is the derivative of 3t squared, which is 6t, and dy dt is going to be also, oh no, that will be 6t squared. And so arc length, which is represented by s, is equal to the integral, and we're going to go from 1 to 3 as is outlined by the interval in the problem. And then we have the square root of x prime, which is 6t squared, plus y prime, which is 6t squared, dt. All right, so we can go ahead and simplify our integral. You know, the integral from 1 to 3, square root 36t squared plus 36t to the fourth. And we have a GCF we can pull out of that square root, or the part inside the square root, because we can pull out a 36t squared, which leaves 1 plus t squared. And then, of course, the square root of 36t squared is 6t, so we have 6t times the square root of 1 plus t squared. And that's as far as we can simplify. So now we need to talk about, okay, which integration method do we choose? We just spent a lot of time in chapter 3, plus we have substitution method, use substitution available. So which method is going to be the best method here? And hopefully pick the u substitution as the best method, because we want to let u equal 1 plus t squared, recognizing that the derivative of t squared is 2t, and we have this extra t floating around here. We know that du is 2t dt, meaning dt equals du over 2t. And now we can go ahead and substitute. We're going to get the integral of 6t times the square root of u, and then dt is du over 2t. We need to change our limits. When t is equal to 1, we get 1 plus 1 squared, which is 2. And when t equals 3, we get 1 plus 3 squared, which is 10. We also know that 2t goes into 6t 3 times. So we're going to get 3, and we want to treat this as a power, so we have the integral from 2 to 10 of u to the 1/2 du. And we use the power rule, we get u to the 3/2 times 2/3. All right, evaluated from 2 to 10. 3 times 2/3 is just 2. So we get 2 times 10 to the 3/2 minus 2 to the 3/2. And just to kind of talk about what that is from a decimal point of view, this is about 57.589. And that's going to do it for this example. Let me know if you have any questions. We'll see you next time. Thank you.